Want to nail engineering manager interviews at MAANG and other top-tier companies? You can with USA's #1 tech interview prep platform. We have 300 plus SMEs and instructors from top-tier tech companies to help you land your dream job. We've helped thousands of engineers make their way into MAANG. You could be next. To learn more, register for our free webinar.
So you've been engineering manager, right? And you're looking to get in as an engineering manager.
Yeah, basically
Okay.
EM role. I'm applying for EM role, similar role that I'm. Of course, they're coming in at different levels, and of course, the target companies are the Faang plus companies. Right now, I'm not in a company. So.
Okay. And so you want like a system design interview, or is that what you're thinking?
Machine. Well, that's another thing. So I assume since you have assigned to me, you are normally sitting on the panel for this type of roles, correct? Like EMs for ML.
Sorry, ask that again. My headphones cut out for a second.
Oh, so my question would be, what type of things I should expect in the interview section of the Faang Plus companies for EM for ML, EM for AI or data science or things like that.
Yeah. So I would expect. So it's different everywhere. You're doing Faang, like you're doing a Faang company. Did you say which one? Google,
Facebook, Microsoft, Amazon.
Okay. So
and Apple's quite different. So the one, and also the ones that are copying these companies. So so I assume I have a few machine learning system design. I assume I have behavioral question, managerial leadership question rounds. I would say, not the question, rounds, right? What else?
So you'll typically, to my understanding, so they're all a little bit different, right? So if you're at, like even team to team, so it depends on what team, the specifically the team. So you'll typically be under, if you're a manager, senior manager, you'll typically be under a director or a VP, right? Depending on the structure. And so with them, so you'll have basically like a regular machine learning interview, except it'll be a little bit lighter. Like the engineering will be a little bit lighter than you would, typical. And then hold on, let me move these things around so I can see everything. And then they'll do some like manager questions for like they'll likely have like one or two discussions about your manager experience. So you'll need. I honestly am not 100% sure if you'll have a coding round as a manager or not, but I believe you will have a machine learning or at least some type of system design, typically machine learning system design or something like that. But there'll be a lot more behavioral. The emphasis, my understanding is the emphasis will be a lot more on the behavioral questions, like conflict resolution, all those types of things that you would expect to do as a manager. But they'll be a little bit lighter on ML. But as a manager, as you know, you'll have to understand what your reports are doing. So
of course,
you'll need to, you need to have at least some skill level, in there.
So with IK, I have done mock interviews with leaderships and behavioral. I have done mock interview for machine learning system design. A few. I have done mock interviews with general system design, which backend system design. I'm not sure if I get it because the machine learning system design would be very different from the backend system design. Correct? So I'm not sure.
Yeah, they're different. I mean, I guess Yeah, the focus is different. So machine learning system design, I'm focused on, obviously machine learning components, and so like the metrics, etc., are, they're
Okay.
concentrated around those types of performance. Whereas, back end, or I just call it like typical system design or software system design, those are like throughput, QPS. So all of the metrics are related to how performant it is in terms of,
Yeah.
speed and all that type of stuff.
So I
And
assume,
yeah,
yeah.
and like
Go ahead.
pub sub sidecar, all that stuff is in those.
Yeah, I
Yeah,
understood. Sharding, I don't know, like caching systems. How do you design
yeah.
things like? All right. So let's say, well, I was looking at your resume, and the reason that I chose this link provider, I think that I chose machine learning mock interview for this
Okay,
on the IK panel. So I think let's focus on the machine learning. I'll let you decide. Do you want to make it breadth or depth? Because I think I would get all sort of questions in the real interview in the under the domain of machine learning. Based on what you are familiar with, you guided. I'll follow your lead and try to.
okay.
I assume this would
So,
be.
so just to clarify, you said you wanted a machine learning system design. That's what you're thinking.
Yeah, machine learning system design or machine learning algorithms is fine too. So
Okay, yeah,
if I have to, but they can get combined too. I don't know how do you guys conduct
yeah,
it,
it kind of
intertwine together.
yeah, it depends. So the interview can go in either direction usually.
All right, so
Um,
let's do that.
okay. Could you design a system that will that attaches to something like what we're actually, wait, pause. We need, do you have,
Do
I
you
was
need
just looking at
or
CodeBunk. Yeah, we need like a whiteboarding or something. CodeBunk doesn't have it, I don't think. Like if you're on like, Google Drive, if you can just share your screen, that would work fine. Like
Google
Google,
Drive? I mean Google
or
Docs.
Google Docs or Draw, or whatever you want is, all, it doesn't really matter
All
to
right.
me.
So that's another thing. So in the interview setup, don't they expect I do it on their own platform?
Yeah. The each one's different though, so
Does that mean that
you
I have to get myself familiar with the most common ones also? Because sometimes that might be on your way of the way that you smoothly explain your problems.
I would basically get good at learning them on the fly. Like, so they're all more or less the same, and so it's
Okay.
usually a better plan to just um you know
Yeah.
that you see what I'm saying, because you can't learn them all. There's ever, and then as soon as you think you have, there'll be a new one.
Always. That's like
So
machine learning tools.
yeah, Google Docs are fine. Like, so you'll probably want to draw a little bit, but it's this works fine
Yeah.
too.
Excalibur is also fine too. So do you see my Google Doc? Like,
Yeah, I can see.
okay, so we can use that and see how it goes.
Yeah.
And
All
sometimes I
right.
have seen people interview such in a way that we only discuss. We don't really type anything or draw anything, which I
Yeah,
found a little bit awkward. But I think that happens.
it's I mean, it's usually, if I have a opportunity to put things down, like, so from an interview perspective or interviewer perspective, I mean, I'm sure you know this too. It's a lot easier to follow somebody's
Structure.
while they're drawing, because when you're listening to someone, it's like you'll miss a little bit and then you'll try to play catch up, but you can't catch up because so
Yep, understood.
yeah.
Yeah. As I said, I follow your lead. You're the interviewer, and we're mimicking the real interview. So
Yeah. So this will work. Okay. So all right. So back to interview mode. Can you design a audio transcription system for video calls? Like, so for example, this video call, but we've two people here, but maybe there's multiple, 10 people in a call, and you would want to know who's talking, what they're saying. And you can assume it would be a single language everyone was speaking, like, we can assume English, but it doesn't really, what language it doesn't matter. It's everyone speaking the same language.
The point here is that the language is not getting exchanged or changed.
Yeah. There's no translation.
There's no translation here. Okay, very good. So design a video call transcription, multiple people in the call, and of course I assume this is a live, so you would like the transcription happens live.
Yep. Yeah.
So, and okay, live.
Real time.
Real time. Inference. Real time. These are the requirements. So very good. I think I normally in this sort of interview setups, I try to clarify some conditions about the setup. You mentioned a few of them already. I just wanted to know again, what would be who are the people who are using it? Who are the users?
So they'll be, typical office workers, people like, us essentially. So it would be like, so imagine the people using, Google or not using, Google Meet or Teams or Zoom, to do business calls, and they want something so they can record transcripts of the meetings, and potentially for even could be useful for things like closed captioning for audio impaired, things like that.
Very good. In terms of the load like QPS, RPS, how many users we expect to use it? Well, of course, in each meeting, there's the handful of people, maybe at most 100 people. But in general, the traffic comes out to our system. So, how many people we expect? How many basically requests per second?
So there'd probably be maybe 10 million users concurrently. So power so this can exist in the cloud, so we can scale it. We can scale it as necessary.
Horizontally. So basically, you would like me to focus on the machine learning part of it, not the scalable aspect of it.
Yeah, I think so it'll need to be something that's scaled, but they're like in terms of the models and things will be. All right. You'll be able to use central models, but you'll be able to replicate.
Certainly. All right. Very good. So I start with a general block diagram, and I normally start with the inference mode to make sure that we know. I make sure that I understood and we communicate on the inference mode. And then I'll go ahead and on the training part and how we build any of these models and where the data come from and things like that. Okay. How does that sound?
Sounds good.
Awesome. So I need a bunch of boxes. Obviously, let me see if I. How do I get boxes? Like,
I think 2 down, drawing maybe.
Drawing, normally I think, yeah.
Oh, I see.
So if it was PowerPoint or Google presentation, it would come as a default, but that's fine. I think.
Yeah. It does like.
That's okay. I think
we're working with what we have. It's all good.
You still see this page, right? You still see this page, right?
Yep. I can see.
All right. So the input. So this is the user. I don't know how to. So this is the user. Or let's say call it client. Font right. So the client would be in this case the Zoom app or the Google Meet app, or Google Hangout browser or app on the user side. So this is going to be our API gateway, right? And here would be the rest of our backend. So of course there's a load balancer and things like that. We can talk about the scalability of that aspects. So here, our sequence of the machine learning models happens. So here is our ASR, or acoustic model, ASR, which basically what happens here is that and basically this is acoustic model which gets the voice signal and convert the voice into a sequence of the so-called phoneme in speech recognition. And then after that, the language model gets involved, the language model. And since we said there is no translation, so we have one language model here for that language. And of course, the ASR also is for that language that we know the clients are talking into that. So that's a condition considering. I separated the, so basically if I want to be more specific, this is acoustic model, and both together we can call it, both together we should call it ASR.
Okay, so the acoustic model converts sounds to words, and the language model converts words to sound, or words to.
So this is
words to like sentences.
Yeah, I'll zoom into this. So this is the input here to this are so inside here there are two components. One here is that gets the temporal signal of the voice, the actual audio signal, and converted to the MFCC features or spectrogram signals.
I see.
And then there's a model that model normally, well, traditionally called GMM HMM models. Or these days are neural network end-to-end. Regardless of how that piece is implemented, we can actually talk about the architecture of that. But just putting a functional component here, we can discuss about the how we design each of them. But then this output is just the sequence of the phonemes.
Okay, so and really the AM is like a pre-processing step. Transform.
It's several type of transform. Several transform happens.
Yeah.
Because of what, and then what basically generates the probabilistic. So the probability for each frame in your acoustic signal, it generates a probability of the top K probability of the phonemes associated with that phoneme, and there are several sequences can happen, right? Then you say, okay, hey James, I think for this project we have to do this. This hey James for this project is a few seconds of the acoustic data, but each frame of it could have actually multiple phonemes in it, and then the way that acoustic models generally works, it basically tries to find the maximum sequence, not just maximizing per. Well, I guess that the simplest way to build it would be just classify each frame independently to a phoneme, but normally that's not the way that it's built. The higher quality of signal you maximize for the whole sequence. That's why sometimes I've seen. When the signal goes to the end of the sentence, sometimes the second word, the word that is not the end of the sequence, can get updated. The transcription of that can get updated, right? So that's what. And then this is just basically you get a tree structure of all the paths that each path is the final phoneme sequence. Phoneme is like a phonetics type of sequence, and then that gets intersected or merged with the language model, and it actually puts the words next to it. There are recent works that they're combining these two together. We call it end-to-end models, but there are different ways of modeling these things. At the end here, what happens here is the actual transcription. So here it says, hey James, I think in this project, something like that. We shall blah blah.
Okay.
Right, and the language model, of course, put many things in it. Gets the semantic into the play, gets the grammar correct, and basically the probability of the last language model depends on whether it's 1 gram or 2 gram or any different kinds. It basically generates the next word or token, we should say. depending on the previous ones, and there is a sequence.
Yeah, makes sense.
So that's basically is the high level. So we are basically, the scope of the your question is only on until the end of the transcription, right? So we are not going to automatically take any sort of action.
No, we'll just give it back. So it'll kind of be like, this person said this, like a movie script kind of,
Yeah.
First, user one said this, user two then said this, and we'd like have like a window where it.
Yeah. So I assume then we have just returned it back to the okay. You just return it back to the user. Okay. Yeah.
There it is. Okay.
I have to do it two times, so I get it.
Okay.
All right, and I guess that's the end. Oops, the other way around. Okay.
I get it. Yeah, that's fine.
All right. So this is the output. Now, is it good? Can we? This is for inference mode.
So I guess where's the client is the client? Does that mean that's like my computer?
Yeah. Well, as I said, the client is either the app on your phone or on your machine or the browser.
So So what's inside the API gateway? Is that if I'm speaking to you, it's going it's being sent somewhere right now and then sent to you, right?
Yeah, well, there are a couple of nuances here. This is just one design. So this part or a few of these parts could actually be built in your client, right? It could be on device, could be built in your phone, right? What part of it that's alternative design. So that becomes a little bit on device aspect. So the hybrid design, a part of it is on device, part of it is on the backend cloud. Regardless of that, there is the API gateway here, which is basically your Google Cloud endpoint or your AWS endpoint. There is a load balancer inside that. DNS conversion, all of these aspects will happen inside that. So this API gateway also, we can actually see it as the stateless machine, or it could be actually a stateful, and that basically. So if we horizontally scale this microservice here, this big box, or a sequence, might be several microservices here. So this API gateway's responsibility would be just to pass the traffic to any of these pods, basically in your backend cloud. So there is a load balancer inside this and things like that. So this the system design aspects of the work.
Okay.
Yeah.
So basically, it could exist. So the processing, the transcript could be local, and then it just sends text. And then it, or the acoustic model could be local, or.
No, the pre-processing. I wouldn't deploy acoustic model local, which is a heavy model. The feature extraction, for example, converting the temporal signal to the frequency, like Fourier transform, for example, or wavelet transform. Whatever your signal transformation is, actually gets deployed on the client. These days we have. I think we have advanced in the community so well in terms of the model compression that we can actually put more models on the devices, and devices are more powerful too. Depending on what device we're talking about. Like if it is your browser, probably we can run a lot lighter models on it. But if it is your phone and you're talking about the Zoom app, for example, or Google Meet app, then yes, then you can actually have a much more of this functionality here. And again, acoustic model. If I wanted to just make it a little bit more elaborate here, acoustic model inside. If you zoom in on the acoustic model, let's say this is acoustic model. AM. Inside there are some bunch of logical components in it. This is necessarily not a microservice, but this is the feature extraction, which basically example would be FFT, for example, right? So basically, the input that is the audio signal in a temporal format, and the output is the MMCC features.
Okay.
And then this part gets moved inside the client. But the sequence would be the same thing. The role of API gateway would be the same thing as well. Does it make sense?
Yeah.
All right. So one thing that it was in your requirements, I guess, that which I haven't covered it here yet. I'm sorry. Let me just complete this. I think when you nodded, I stopped. So this is the rest of acoustic model is GMM, HMM, or DNN, right? And I think that's the okay.
Yeah. You don't need to draw all the arrows. Okay.
So now there is one piece. So we would like to basically say this transcription came from this person, that transcription came from this person, right?
Right.
We don't want to just transcribe the whole thing. We want to separate the transcription per user, correct?
Right.
Right. And so here's my question. Do we know the users, or there might be the case that a few of the people are sitting in front of the same client? Let's say you are in the meeting room and a few people are sitting in front of the same Google Hangout login. So there, when you take turn in your discussion, but from the system perspective, coming from the same IP.
So yeah, you're basically asking like if some people are in a meeting room, so there's 4 people in a conference room and they're talking to other people that are in front of their computer, how do you handle the people in the conference room? That's what you're asking, more or less? Did I lose you?
I didn't hear that the first part of your.
Oh, sure. So I was saying that. So say you have a meeting and some of the attendees are in a conference room. So say 5 people are in a room. In with one camera and mic, and then a bunch of other people are in, are in their own computer.
No.
Like, is that what you're talking about?
Yeah. Well, the setup is this. I have to identify the users, right?
Right.
And say this user, regardless of not identify. I have to separate the users, right? I don't necessarily need to know James is James and Mo is Mo.
Yeah.
I just need to know James and Mo are 2 different people. ... Speaker to ... Okay.
Yeah. So if we're talking about rooms with multiple people in them, I guess how could we? So I mean, there's a couple of options there, right? Like, so essentially, if it's just me and you, it's really easy, right? Like I can talk and all of the audios from the same person because I'm not in a meeting room. It's just me talking. But if I was in a meeting room, then you wouldn't know who's, one IP could be 3 different speakers or whatever. That's what you're saying, right? It's kind of what you're asking. How do you handle the meeting room? So you're asking what the requirement would be for meeting rooms, or you just ask like, so this is the requirement for speaker, like it would say like speaker 1 said this, speaker 2 said this. That's correct. But in the chat, when you're if some of the speakers are in a meeting room, so there's 3 speakers per 1 IP, then you're essentially asking like, what do we do in that situation?
Yeah, well, I just wanted to know if that's the condition. So because if that's the case, then I have to handle it in my model. I have to have another model. I have to have another model that actually identifies, separates the same signal that comes from the same IP.
Okay, so I guess let's think about the options there a little bit with that. Like we can talk about the options more than we can, than pick one. So I guess, what are some of the ways you could handle that?
Okay. Well, the simplest case here is that, which is not, I think, the ideal scenario here, is that assume each client has its client ID, could be IP, could be any other client ID. Could be your logging, your Zoom login account, or anything that is the unique identifier of the client. And then I basically transcribe the signal coming from the same client, and assume that's one speaker. Then that's easy, right? So
right.
each traffic comes is already gets separated based on the account. So from the machine learning perspective or speech recognition perspective, is going to be the same thing. The audio signal goes in, gets transcribed, and we know it already ahead of time that which client was. So then we just put that client ID here, right? That's it. That's the one option. But in a scenario that multiple people are sitting in front of the same client in a room, and there's one login, but there's different people are talking to let's say 3 people are next to you right now, and I am on the other side. So in that scenario, those 3 people that are using the same client, their voices will be combined. So if we want to handle that, basically the transcription gets done. If we want to handle that, then we have to basically separate that based on their acoustic signature of their voice.
Okay. One thing we can do is we can assume that we'll know, like there'll be a difference between like a meeting room client versus a single, from the perspective of the app. So like, even if there's multiple people in this room with me right now, I'm assigned one tag. So if like my wife comes in and start talking, the audio transcription will assume it's her. If I'm in a meeting room, the client or the server, I guess both the client and the server will know. So the server will be able to notify, or the client will be able to notify that, okay, this is a multi-user node. Okay. Does that make sense?
It does. It does make sense, right? In that case, and or one option would be you have a way of identifying how many people or there are multiple people using your client, and that comes as a message to our server. Or the system can identify that using the type of device that you are using. If you're using your personal computer, or if you're using the in the meeting rooms, there are standalone microphones, I guess.
So you can assume that the rooms are like enabled, in some way. So either the room, like the meeting rooms will identify that they're multi-user versus single user. So you could do it. I agree in what you're saying. There's multiple ways to do that. Like you could automatically figure that out. It could be a different device. So all of those are valid.
So multi-user multiplexer, I should say, or condition multiplexer.
Yeah. Well, so
I think I put a component here. I put a multi-user or not.
Yeah.
Multi-user or not, and then if there is multi-user, if this is the meeting room scenario, then it has to basically pass to this.
Okay.
And comes to this, right?
Okay. Yeah.
But if the answer is no, then directly signal goes to AM.
Yeah. So the cloud computing would be responsible for identifying speakers, speaker identification in the multi-user case.
Correct. Correct. And again, if we have a good device, and in many cases we would, then this would be also another candidate similar to the feature extraction that we can actually deploy on the device, because that would be not this. I'm sorry. Yeah, I see this logic too. This logic too, and also this piece.
Yeah, or even extra features to increase speaker identification.
Yeah,
you know, like relative. You know, like you could judge distance. You know, there's things in there that you could add. You could add some structured data to the packets, or you know, you could do something.
Correct.
Yeah.
In fact, we can actually factor out that piece. Honestly, that's another thing. So this part. So this feature extraction component, which is inside the AM, this can be common between this model and this model. So then we might actually have this here, and I'm breaking each logical component actually right now. Breaking down each logical component. This might be actually this way, because that's a low-level transformation, and that has to be done regardless of any component, right? So that's that goes inside this. And then I guess we need one of these. So I'm separating the low-level aspects of.
Yeah. So basically, the speaker identification would tag it with.
Based on the MFCC features. Based on the free. The only thing that this component little guy does is transform from the temporal domain to the spectral domain.
Okay. And then it would use that to, so essentially speaker identification,
is a classic
it's a router, right? Like it splits data. So a bunch of information comes in, and then what comes out is like speaker one, here's their data. Speaker two, here's their data. It doesn't know what the words are necessarily.
Exactly.
But it just splits it up. Okay.
Yeah. It's not really a router. It's tagger. It's tagger.
Yeah.
It's tagger. Yeah. So basically the features gets tagged. So if I want to draw something else like this, let's say this is your acoustic signal. This is MFCC features, right? Each band, this is a sequence of the band. This is frequency level, and this is time, right? These are like frequencies here. You see my mouse cursor?
Mm-hmm.
Right. So these are the temporal signal comes into this box and gets transformed to the Fourier space, and 25 millisecond normally is the window size. And then what happens here is that this is the only thing that this component has done is just converted to the frequency domain. Then what happens, it goes, if you have to call a speaker identification or a speaker separation, because we are not really identifying, we are not really saying who is each person. We are just saying this is the different people. And the key here is that the voice or features of the voice of the same people always go to the same people. We are not really separating that. As long as basically you are identifying there are 5 people talking to this they're in meeting room. And then this particular chunk of the voice that came in, because people alternate their discussion, right? That always is for this person. So it's sort of the clustering mechanism. It is actually implemented in a clustering fashion. And what happens here is that, and then it basically sequence of the frequency here is just tags them: speaker 1 is speaker 2 is speaker 1 is speaker 2 is speaker 1 is speaker 1 is speaker 2. So it just tags these things here. But then the same sequence goes to acoustic model. We are not only sending the speaker 1's sequence to an acoustic model or a speaker 2's. We are sending the same temporal structure to the acoustic model and to the language model, but they are already tagged. And then at the presentation time, when we are showing it to user, we are just separating the transcription for this chunk Does it make sense? So here,
yeah. So it goes from unstructured to semi-structured, and then once you're in the labeled, once you've figured out what the words are, you have fully structured data.
Correct. And the reason for that here is that we would like to keep the sequence as is at this level inside these models, because there is a context in it. The sentence that you're mentioning is a follow-up of the sentence that I said in the previous part, right? And good language models capture that context, right?
Okay.
And the quality of because we are talking about, there is an assumption here that there's a meaningful conversation going on, right? So
Right.
so if you separate them, if I cut off this chunk and take it out, so I lose the before and after context of it. In a long tease, like a few minutes, it's okay, because we care about the context in the level of second. But in the level of the milliseconds separating people, would lose the context inside the language model. That's why you would like to keep the entire sequence, but you tag them or label them based on each user. Okay. And then after that, and you would like this speaker identification to be on. You might ask, why not transcribe everything and then label each speaker once everything is transcribed? But at that point, we are left with only the words, and you don't have the signature of the.
Would the acoustic model have the ability to correct speaker separation?
No, their job is different.
So they're basically getting a finite. I mean, it's essentially they're getting, like, you could, in parallel, you could process all the speakers. The only thing you would need to make sure you did was, when you transcribe it or when you output it, you need to make sure your ordering is correct. Yeah. So you need to basically timestamp or whatever, like you need to, keep the ordering correct.
Correct.
Okay.
So basically, these two steps are. I'm just trying to find a little bit of move to organize the components. These two lines of the work are parallel. This line.
Okay.
Actually, this doesn't have to be here. This actually can go all the way to not the language model. Let me just organize my components also for better readability. All right. So there is a. We can actually add. Now we are talking about more details of the design. So we can actually have here a piece of non-machine learning piece, but I don't know, output.
Like a post processing.
Post processing would be a post processing. Processing, and then what happens here? What happens here is that it just organizes the output just the way that this and this has to be presented, and maybe and also make it a JSON output out of it to be able to be ready to in the right way send the right format to the client, back to the client. So what happened here is I just wanted to say this route of the, sorry for the bad arrows, right? So
no, you're good. So what happens with this if two people are in a meeting room and they're talking over each other, someone there, there's a quick back and forth between two people, or they're, you see what I'm saying? Maybe not necessarily like literally like talking at the same time, but like a little bit at the same time. There's lots of overlap. How do we?
Yeah.
How will this model handle that?
Good question. Depends on what's the resolution that we are handling here. The lower route does its job. It just transcribes everything, right? The issue might, what you're saying, that will appear when the speaker identification separation won't be able to separate the overlapping signal, right? And cannot basically understand that the user changed. That fast if people like cutting each other or stepping over each other, right? But the signal comes. The signal comes, and we can transcribe it. But then we are not separating. So there is a chance that a few of the words of one of speaker will be transcribed in front of the others. So you might say this piece of the word, the beginning of what you're saying, might actually get mingled inside or at the end of what I said, right?
Yeah.
But then that happens. But the resolution we are talking about, these MMCC features, these are working, are in the level of 25 milliseconds.
Okay.
Right? So each frame in acoustic modeling is very short. 25 milliseconds is quite a short time in terms of when you're swinging over each other. So we are that little overlap. One word might be tens of frames, right? And then when people are stepping over each other, they have to basically so they're that overlapping in the signal level takes like 10 frames or 5 frames or 6 frames if this is very short, right?
Okay.
So that's basically long enough, although for a human is very short, for long enough for these models for these models to basically capture it, and the user changed. Does it make sense?
Yeah. Well, so it might affect the language model though, right? Because if two people say a word at the same time, that word's gonna get jumbled. But that might be okay. Like you'll just lose a word. You lose a couple of words there.
Well, if acoustic model can get the phoneme out of it, the language model will take care of that, right? So you get the word.
So
can confuse this guy. That confuse acoustic model, not necessarily. Well, if acoustic model gets confused, language model gets confused too, right? Because you have to, the output of this passes to this, but they're acting on a different resolution, different level of the resolution. So you might miss a phoneme, right? Well, otherwise people just argue and talk over each other, right? Like
right.
for fighting. Or arguing, and then the span of the time that they are mingling their signal, basically from the system perspective, is long, and then there is a chance that our acoustic model gets confused, and hence our language model gets confused.
Okay. All right, that makes sense.
Yeah.
Okay, cool. So I mean, this might be a good stopping point. We can sort of discuss a little bit, and you can, if you have any other questions, and sort of go from there. Is that
very good? Sure. Don't you want to talk about? Oh, we are over time. I thought we want to cover the training aspects of it, where the data come from.
Yeah, maybe let's do a quick. I mean, yeah, well, let's maybe spend like 3 or 4 minutes, like do the quick version, and I won't judge you on the speed. You know, these hours aren't long enough. We need like an hour and 20 minutes for these interviews, because we have to like sync up first. But anyway,
I don't want to rush into this. I want to also, we still have time for your feedback.
Yeah, I mean, I think honestly, I think we have enough here that yeah. So like in a real interview, you definitely go into training. Like that's, you should do that for sure. Don't skip that.
And evaluation and things like that. Yeah.
So that's what I was going to say, is that, so typically, well, first of all, you did really good at gathering requirements. Like you clearly understood, you asked pertinent questions, you narrowed things down quickly, to get to the heart of the problem. You're able to, break it down into the different parts that you would need. Because the one thing that I would think about during your calls, though, is as a manager and a senior manager, you want to think a little bit more about the business side, like the business impact. So like, okay, you did a lot of great questions on that side. Who are the users? Who are what's the requirements? But you may want to get into, okay, what's the value? So like understand the business value of this, of whatever you're making, and so that can like help. So that's just like a small note. So In terms of a
right.
regular machine learning interview, you did fantastic in terms of requirements. So, but as a manager, senior manager, they may expect you to go a little bit more into, okay, like why we built, not too deep. So it's more like you have like some understanding of sort of what what the priorities are as a manager on you know on this thing. And so to do that, you often need to know, like, okay, how are we making money from this? Is this for audio? Is this for closed captioning? And that can lead to ADA issues for other people, or like what, like all those types of things. ADA is the American Disability Act. So like that's just for the specific example. Like maybe it's not, maybe there's no liability at all. So okay. And then you skipped a little bit, or you skipped metrics. So you didn't really talk about like, okay, how are we going to measure success of this thing? So that's something you at least want to touch on a little bit, is like okay, like what, especially the online metrics, like how are we going to measure how well this is doing in the field?
Yeah.
Or at least discussing it a little bit. For this one, it's a little bit difficult because there's not like, there's not clear cut feedback. Like people aren't going to correct the transcripts most likely.
Well, depends on the application too. Like if it is CX automation, then the happiness of the user, there are metrics for that, right? So how fast the tickets gets resolved or things like that.
Yeah.
Or how many less complaint we get, or reopening the issues if it's CX automation. I think that becomes very application specific, or how many times they re-say they need to re-speak what they said.
Yeah, there's a couple of things there, but I mean, all of those are kind of difficult too, right? Like, because how do you? Okay. But you could talk about like, so measuring performance of this thing is going to be a little tricky. We're going to have to rely a lot on user feedback, and like we can do some post processing on if some slower processing on things, to do like a slow model that does a really good job on this, and do sort of spot checks, because a real-time model versus is just going to be less performant than something that can take forever. And so you could use the slow model to help find errors, and that would be one way to do it.
To compare the real time to the teacher model, let's say. Or
exactly.
Master model. The gap in between.
That would, so those types of things. So then you're diagramming and your explanation. So you did an explanation, and your diagram were both really strong. Like you were very clear on your explanation. You clearly knew what you were talking about. You had expertise. When I threw a curveball in there with multiple users, that like, well, you kind of saw the curveball coming, but then you handled it very well with multiple options on how to fix it, and then how to how to adapt the system to compensate for that. So in terms of your high level diagram, and you kind of did a deep dive while you were going through your high level, which is okay, especially for an engineering manager. Like, I don't think you sort of stuck at the high level, and you kind of dug in deeper when I asked questions, which is exactly what you want to do. And so I thought that was really, you did a fantastic job with that. So I mean, overall, I thought it was a very good interview. So awesome. Skipping the online metrics. So like the monetization business impact, that's all kind of tied together. Like, thinking about the cost, all of that thing. So it also depends on the interview. So if this was a purely if you're like going for less of a product side, then that won't really be necessary, right? Like if you're going for, or if it's not product side, if you're going for a research manager, they don't really talk about monetization as much. But if you're building products and someone has an idea, you usually want to understand how it will make money, or how it will impact business, what its business use is. But yeah, so that's I thought you did very well.
Thank you so much for the feedbacks too. Really appreciate that.